tutorial on this chapter. If not, link has been given in the description box. You can check it first. Today in this lecture, we are going to cover more problems on fundamental principle of counting. Then we will learn what is the meaning of nPr. Then we will go for restricted permutation. And we will do permutation of alike objects. Those who are new to my channel, please do subscribe and press the bell icon so that you get all the notifications of all videos I upload to this channel. And if you really like my teaching, don't forget to share and like my videos. Comment me if you have any question where I can help you to progress your preparation for IIT JEE. So let's get started. So we will start our lecture today on fundamental principle of counting. Though we have already completed fundamental principle of counting, and along with that we have solved a lot of sums in the previous lecture. So in this class we will start with the fundamental principle of counting and we will go for doing some problems based on this. So let me just give a quick revision for this. Fundamental principle of counting, as I have discussed, that if you have two jobs, J1 and J2, and if J1 job can be accomplished in m ways and job J2 be accomplished in n ways, then total number of ways in which the work can be accomplished when J1 and J2 both are involved. The work can be done with J1 and J2, then the total number of ways becomes m into n ways, right? And if the job can be done in either by J1 work or by J2 work, that is, the complete work will be accomplished either by J1 or by J2. When OR is involved, then the total number of ways is m plus n ways. This is all about your fundamental principle of counting that we have already discussed in the previous tutorial. So let us do some problems based on this and let us continue our today's class. See this question. Find the number of 6-digit integers which can be formed such that repetition of digits is not allowed. This is the first one. Repetition of digits are not allowed, and we have to form a 6-digit number. So this place can be filled in any of the 9 digits. That is, from 1 to 9 we are having 9 digits. So the first place can be filled in 9 different ways. Why? Because 0 cannot come in the first place. The second place, as the digits cannot be repeated, it can be filled in again 9 different ways. Can you tell me why? Because now at this place your 0 can come. In the first place 0 cannot come, otherwise it will no more remain a 6-digit number, it will become a 5-digit number. But in the second place 0 can come, there is no problem. Therefore this place can be filled in 9 different ways, because 1 digit we have already taken in the first place, so which cannot be used anywhere in the 6 digits. The third place again can be filled in 8 different ways, 7, 6 and 5 different ways. Therefore, total number of digits so formed where no digits are repeated will be 9 into 9 into 8 into 7 into 6 into 5. This is the total number of ways. And what is that? If you calculate, you will get 81, 56 into 30. So what will be the answer? 56 into 30 gives us 1680. So this is 81 into 1680. That gives us 136080. So this is the answer for the first part of this question. Now the second question is, now you have to form the 6-digit number where digits can be repeated. So again, let me draw 6 places. So this place can be filled in any of the 9 ways. Again, the same argument. This place cannot be filled with 0. Otherwise, it will no more remain a 6-digit number. The second place, now we don't have any restriction. Any digit can come. So it will be filled in 10 ways. This is also 10 ways. This place is also 10 ways. And this place is also 10 ways. Therefore, the total number of such digits possible is, the total number possible is 9 into 10 to the power 5. Have you understood this? Because the first place cannot be filled with 0. That is why I have chosen this. The first place will be filled in 9 different ways. But from the second place, we don't have any restriction. The digit which we have already used, we can use it again. So there are 10 ways of filling that second place. Similarly, third, fourth, fifth and sixth places. Therefore, the total number of ways will be 9 into 10 to the power 5. Is it clear to everyone? Is this problem clear to everyone? Okay, let's move for the next one. See this question. Find the number of 6-digit integers which are greater than 25, that is 2,50,000. So you have to form 6-digit number in which all the numbers will be greater than 250000, that is 2,50,000. The first case says that repetition of digits is not allowed. You cannot repeat any digit in these 6 places. So in how many different ways you can form the numbers which are more than 2,50,000? Now, listen it very carefully. No digits can be repeated. And it should be greater than 2,50,000. So, just think about it. If this place is filled by any of the numbers between 3 to 9, if this place is filled by any of these numbers from 3 to 9, we are having 7 digits here. So if any of these digits fills this place for this 6-digit number, it will be definitely greater than 2,50,000. If any number, 6-digit number starting with 3 is definitely greater than 2,50,000, no doubt about it. So the first place can be filled in 7 different ways. Now what about the second place? This place can be filled in, no digits are repeated. So whatever digit you have used here, I cannot use it here. So what are the total number of digits that are left with us? 9 digits. So this place can be filled in 9 different ways. Third place can be filled in 8 different ways. This place can be filled in 7 different ways. This place can be filled in 6 different ways. And this place can be filled in 5 different ways. So, the total number of digits so formed will be 7 into 9 into 8 into 7 into 6 into 5, which are all greater than 2,50,000. Because we have started all those numbers with 3 and above digit. So naturally it will be more than 2,50,000. Now this is case 1. Let us consider case 2. When this place is 2. When the first place is filled with 2, now we will be very careful about it. Because the number should be greater than 2,50,000 and no digits are repeated. So the second place can be filled by any of the numbers from 5 to 9. That is, this place can be filled with any digit from 5 to 9. That is, there are 5 ways of filling this place. Is it clear or not? Your number should be more than 250,000. So the second place, the numbers in the second place, when it is starting with 0, when it is starting with 2, the second place can be filled with the digits either 5, 6, 7, 8 or 9. Is it clear? Now, this place can be filled in how many different ways? Can you tell me? Already 2 digits are gone. One has been occupied by the first place and the second one has been occupied by the second place. Now we are left with 8 digits. We are left with 8 digits. So this place can be filled in 8 different ways. Naturally, this place will be filled in 7 different ways. This place can be filled in 6 different ways. And this place can be filled in 5 different ways. Is it clear? So when the first digit of the 6-digit number is 2 and the second digit of this 6-digit number is from 5 onwards, that is 5, 6, 7, 8, 9, any of the digits you can use. And when digits are not repeated, guaranteed all the numbers that will be formed will be more than 250,000. Am I correct? Okay, so what will be the total number of numbers that are formed when it starts with 2? It will be 5 into 8 into 7 into 6 into 5. Am I correct? Therefore, total number of ways, total number of numbers so formed, which are greater than 250,000 will be 7 into 9 into 8 into 7 into 6 into 5. This is case 1, and we are adding this case with case 2, which is 5 into 8 into 7 into 6 into 5. So let me take common. 7 into 9 is there, 5 is there. Let me take common 8 into 7 into 6 into 5. Let me just go for this small calculation. This is 63 plus 8, and this is coming to 7 8s are 56, 5 6 are 30. So 56 into 30 gives us 1680, and this is 68 into 1680. So that gives us, if I multiply this with 68, we are getting 114240. So what is the answer for the first question? The total number of digits so formed is 114240. Is it clear to all of you? Have you understood this? Yes or no? Tell me. Okay. So now, see the second part. In the second part, they have said that repetition of digits is allowed. Now you can repeat the digit. There is no harm. Okay. So, again, we have to consider 2 cases. Case 1. For this 6-digit number, let us say the first place is filled with any of the digits from 3 to 9. That is, there are 7 digits available that this first place can be filled with. Is it clear? So the first place can be filled in 7 different ways. Now we don't have any restriction. We can use the digit which has already been used. So the second place can be filled in 10 different ways. Similarly, the third place, fourth place, fifth place, as well as 6th place. Therefore, from this condition, when the first digit is either 3, 4, 5, 6, 7, 8, 9, the total numbers that will be formed is 7 into 10 to the power 5. Am I correct or not? The first place, if it starts with 3 till 9, all numbers will be more than 2,50,000 and we don't have any restriction. So the other places can be filled in 10 different ways. And there are 5 places, so that can be filled in 10 to the power 5 different ways. So from the first case we are getting total number of such numbers formed is 7 into 10 to the power 5. Now we are considering case 2. Now we will be very careful about it. 6-digit number. This place, the first place, I put it to 2. Okay? Because you cannot take any value which is less than 2,50,000. So the first place is filled with 2. Now, the second place can be filled in any of the numbers from 5 till 9. Because you should be careful, the number should not be less than or equals to 2,50,000. Because the question is, all numbers are greater than 2,50,000. So it cannot be 2,50,000 also. It cannot be. Every number will be more than 2,50,000. So what I'm doing, the second place I'm filling with either 5, 6, 7, 8 or 9. So we are having 5 ways of filling the second place. Now, this place can be filled with any of the 10 digits because we don't have any restriction. So this place can be filled in 10 ways, 10, 10 and again 10. So total number of such numbers formed which are all more than 2,50,000 is this will be, the first place is filled with 2 now. So that is only 1 digit is there. So here there are 5 ways into 10 to the power 4. Am I correct or not? Now, think about it. The second place I told you it can be filled in 5 different ways. Let us say that place is filled with 5. Now from third place onwards, 3rd, 4th, 5th and 6th, what I have done? I have not put any restriction. So any digit can come. So let us say the 3rd digit is 0. The 4th digit is 0. The 5th digit is 0. And the 6th digit is 0. Then your number is coming to 2,50,000. And that number I should not include in our calculation. Why? Because the question is all the numbers should be greater than 2,50,000. Are you getting my point? Therefore, we have to reject that option which has already been considered in this calculation 5 into 10 to the power 4. So in that case, all you will do is you have to simply subtract 1. That is, that particular digit is eliminated, is subtracted from the total number of ways. When it is starting with 2 and the second place is 5 and all other digits are 0, which gives us 2,50,000, which we have excluded. Is it clear? Therefore, the total number of such integers formed when digits can be repeated and more than 2,50,000 will be the sum of case 1 and case 2. Yes? Because either your case 1 can occur or case 2 can occur. So or means you have to go for addition. Therefore, the total number of such digits so formed, such numbers so formed will be 7 into 10 to the power 5 plus 5 into 10 to the power 4 minus 1. So that gives us what? If I take 10 to the power 4 common, so it will be 70 plus 5 minus 1. So that gives us 7510234. minus 1. So that gives us how much? 750000 minus 1. That gives us 749999. Okay? This is the total numbers what we got from case 2 and case 1, because we have already added this too. So what will be the answer for the second one, where the digits can be repeated? It is 749999. Is it clear or not? Here the option is given wrong. This is not 0. It will be actually 74. It's a printing mistake. So it will be 749999. But have you understood the logic of this problem? Absolutely. Okay, let's move for the next problem. This question came in JEE Advanced 2022. It has been said, find the number of 4-digit integers in the closed interval 2022 4482. So you have to find out all the 4 digits number which are lying between this range, and both the extreme values are included, which will be formed using the digits 0, 2, 3, 4, 6, 7. That's it. That's the question. So in this case, it's very clear to us that we have to consider different cases to find out how many such numbers are there in the given range. Now, one very important thing is, in the question they have not mentioned whether the digits will be repeated or not. So you have to understand whether the digits will be repeated or not. It's pretty simple to understand, because they are asking us to find out all the digits between two numbers given. So naturally, numbers between those two given numbers there will be some numbers where the digits will be obviously repeated. So in this kind of questions, they will never tell you whether the digits are repeated or not. That you have to understand. Since they are asking for all the numbers between two numbers, so naturally there will be numbers where the digits are repeated. So you have to take that thing into consideration, that in this problem digits can be repeated. Clear? Now let us consider the first case. 4-digit number. Let us say that this place, the 1000 place, is filled with the digit 2. The 100 place is filled with digit, say, 0. And the 10th place is filled with the digit, let us say, 2. Now, in the unit place, if any digits come from these 5 digits, that is either 2, 3, 4, 6 or 7, then all the numbers will be greater than or equals to 2022, that's for sure. So this place in case 1 can be filled in 5 different ways. Hence, we are going to get 5 such numbers which are more than 2022. Now let us consider case 2. When the first place is filled with the digit 2, the second place is filled again with 0, and the third place, that is the 10th place, if I choose any digit from 3 to 7, if I choose any digit from 3 to 7, then all the numbers so formed will be more than 2022. So this place can be filled in 4 different ways. And since digits can be repeated, so the unit place can be filled in by any of the 6 digits. So there will be 6 such different ways of filling the unit place. Therefore, total numbers so formed will be 6 into 4, that is 24. Is it clear or not? The 1000 place and the 100 place are filled with still with 2 and 0. Now, if the 10th place is filled with the digits 3, 4, 6 or 7, then all the numbers so formed will be naturally more than 2022. So total number such formed will be 4 into 6, that is 24. Now, let us consider case 3. Still, the 1000 place is filled with 2, but the 100 place, if I filled with by any of the digits starting from 2 till 7, if the 100 place is filled by from any digit from 2 to 7, that is the digits given to us 2, 3, 4, 6 and 7, naturally all numbers so formed will be more than 2022. So this place when filled by any of these 5 digits, that is this place can be filled in 5 different ways. Now the 10th place and the unit place, they don't have any restrictions, so any digits can be used, which is used by 6 into 6 ways. Therefore, there will be 180 such numbers that will be formed. Now consider case 4. When the 1000 digit is 3, I have fixed this number there. So now I don't have any restriction in 100, 10 and unit place. So these 3 places can be filled by any of these 6 digits, which can be done in 6 into 6 into 6 different ways, which is nothing but 216. Case 5. When the 1000 place is filled with the number, say 4, and let us consider that the 100 place, because we have to choose all the numbers which are less than 4482. So if the 100 place is filled by any of the digits starting from 0 to 3, then all the numbers, the 4-digit numbers so formed will be less than 4482. So the 3rd place when filled in 3 different ways. The 100 place can be filled in 3 different ways. The 10th place, here there is no restriction. So 6 digits, any of these 6 digits can come here. Same thing with the unit place, any of the 6 digits can come. So total numbers so formed will be 3 into 36, that gives us 108. And you see, all those numbers are less than 4482. Okay, let me consider the other case when the 100 place is filled with 4. If the 100 place is filled with 4, we should be very careful that the number so formed by choosing the digits in 10th and unit place, it should not be more than 4482. But under any circumstances, you choose any value from 0 to 7, no number so formed will be more than 4482. Am I correct? So this place can be filled in by any of the 6 digits. Similarly, the unit place can also be filled by any of the 6 digits. So total number of such numbers formed will be 6 into 6, that is 36. And all those 36 numbers will be less than 4482, that's for sure. Therefore, the total number of 4-digit integers so formed, which is lying in the given interval, will be 24 plus 5 plus 180 plus 216 108 plus 36 again. So let me just add it very fast. This is 60 and this is 5. 65, 180, 216, 108. So we are having 9 and then 1, 9, 15, 2, 3, 4, 5. Am I correct? Oh, I'm sorry. This will be 16, right? So this is 6 actually. So this is 6 and this is 5. So total number of such numbers which exist between 2022 and 4482 is nothing but 569. Is it clear to all? Is this problem clear to all? So what I have done in this case, I have considered different cases. First, I have seen that your 1000 place can be started with which digits. First, we have identified that here the digits can be repeated. So we should be very careful while selecting the digits which is lying between 2022 and 4482. So the 1000 place, I have understood that it will either start with 2, 3 or 4. No other digits can come here. Now when it starts with 2, there are some restrictions because the number should not be less than 2022. And when the 1000 place is 4, we should be careful that no number should exceed 4482. Is it clear? So accordingly we have considered the cases and total number of such numbers formed will be nothing but the summation of all those numbers so formed in different cases. Is it clear? So let's move for the next problem. In this question they have said that if the digits are not allowed to repeat in any number formed, it means no digits are repeated. And you can use the digits only 0, 2, 4, 6 and 8. Then you have to find out all the numbers greater than 10,000. Is it clear? So here what you are doing, you are using all those digits and you have to form, naturally you will form 5-digit number. Otherwise, how a number can be greater than 10,000? Okay, so what I will do here is, so I know that I have to form a 5-digit number and no digits are repeated. So numbers which are more than 10,000 and a 5-digit number, so this place can be filled either by 2, 4, 6 or 8. So this place can be filled in 4 different ways. Am I correct? So now 1 digit will come here. 1 digit will occupy this place. And now we are left with 4 digits. So this place can be filled in 4 different ways because no digits can be repeated. This place can be filled in 3 different ways. This place can be filled in 2 different ways. And this place can be filled in 1 different way. So total numbers of such numbers formed, which are all more than 10,000, will be 4 into 24. So that gives us 96. Is it clear? See, this question came in JEE Main 2021. How simple the sum is. If you have understood how to permute when some restriction is provided in the question, we can handle this kind of problems at ease. Okay, let me take another problem. The total number of 5-digit numbers formed by using the digits 1, 2, 3, 5, 6 and 7. What are the digits that you can use? 1, 2, 3, 5, 6 and 7. Without repetition, no digits will be repeated. And which are multiple of 6? This question is much better. This came in JEE Main 2022. This question is much better, isn't it so? They are saying that the 5 digits number will be formed by the given 6 digits. And all the numbers so formed will be divisible by 6. Now you people all know that what is the rule for checking the divisibility of any number by 6? What is the divisibility rule? The number is to be divided, it has to be divided by 2 as well as it has to be divided by 3. Is it clear? Any digit, any number which is divided by 6, what is the divisibility rule? It has to be divided by 2. At the same time, it has to be divided by 3. Clear? So now, any number which is divisible by 2, the last digit will be definitely an even digit. Isn't it so? Any number which is divisible by 2, it is only possible when the last digit is filled with an even number. And to us, whatever digits has been given to us, we can see that there are only 2 digits there which are even. So the last digit will be filled by 2 different ways, either by 2 or by 6. Yes or no? The last digit, you see, it has to be divided by 6. So it has to be divided by 2 as well as 3. It has to be divided by 2. Whatever numbers we are forming, it has to be divided by 2. It has to be divided by 3. So first I'm checking which are those numbers which are divisible by 2. Any number is divisible by 2 when the last digit is an even digit. Yes or no? So what I'm doing, according to the available digits to us, we can easily see that there are only 2 such digits, which are 2 and 4. So the last place will be filled by these 2 digits only to make it divisible by 2. Am I correct? Okay. So let me take case 1. That is, in the 5-digit number, the last digit, let us place it 2. Let 2 is fixed there. Now we cannot use 2. So what are the digits now available to us? Those are 1, 3, 5, 6 and 7. Now out of these digits, I have to choose 4 digits in such a way that it will be divisible by 3 also. Now, do you know the divisibility rule of by 3? Do you know the divisibility rule by 3? What is that? If you add all the digits, it has to be divided by 3. If it is divisible by 3, then the whole number is divisible by 3. That we know. So now, very wisely, we have to choose these 4 digits. Now, we are having digits, only available digits are 1, 3, 5, 6 and 7. Now, we have to choose 4 digits out of this. So, what are the possibilities? The possibilities are either the digits are 1, 3, 5, 6, or it can be 1, 3, 5, 7, or it can be 1, 3, 6, 7, or it can be 1, 5, 6, 7, or it can be 3, 5, 6, 7. So these are the only 5 cases by virtue of which these 4 places can be filled. Yes or no? Now let us see what is the sum of all those 4 digits for the first one. It is 15. Okay, and what will be the sum of all those digits here? 16. This one, 17. This one, 19. This one, 21. Now, when this number, because the last place has already been filled by 2. So if you add 2, we are getting 17. That's 18. That's 19. That's 21. It's coming to 23. Now, the sum of all those digits which are divisible by 3, we can easily see that they are 18 and 21. Is it clear? So, if we add all the digits, it has to be divisible by 3. Then we will say that, the number which is formed by those digits will be divisible by 3. And eventually it will be divisible by 6 as the last digit is an even one. Are you getting my logic? Okay, so we have to consider this one and this one. That is, these 4 places can be filled by 1, 3, 5, 7 or 1, 5, 6, 7. Now 1, 3, 5, 7, they can arrange in these 4 places in factorial 4 different ways. And 1, 5, 6, 7, they can arrange among these 4 places in factorial 4 different ways. So what are the total number of such digits formed? It's 24 plus 24 gives us 48. I hope this part is very clear to us. These 48 numbers so formed are divisible by 2 as well as 3. Eventually, it is divisible by 6. Now let us consider case 2. In case 2, what I'm doing, I'm fixing the last digit with 6. So these are the 4 digits we have to fill by the digits that we are having here. What are the available digits? 1, 2, 3, 5 and 7. Because 6 has already occupied and you cannot use a digit more than once. So what are the possibilities? It can be 1, 2, 3, 5. It can be 1, 2, 3, 7. It can be 1, 3, 5, 7. It can be 1, 2, 5, 7. Or it can be 2, 3, 5, 7. Right? So these are the the 5 possibilities where we can select the digits such that these 4 places can be filled. Now, what is the sum of all those 4 digits? 11, 13, 16, 15, and that is 17. Now, if I add 6, why? Because 6 is in the last place. It is coming to 17, 19, 22, 21, and that's 23. Now we can easily see that only number which is divisible by 3 is 21. So in the second case, when the last digit is filled with 6, the only available digits are 1, 2, 5, 7. If you arrange those digits in these 4 places, and if you divide all those numbers that we got, will be guaranteed divisible by 6, because it is divisible by 2 as well as 3. So these 4 digits can be placed in these 4 places in factorial 4, that is 24 different ways. Is it clear? Therefore, the total number of numbers that can be formed which are multiple of 6 and a 5-digit number using the digits 1, 2, 3, 5, 6, 7 will be 48 plus 24. So that gives us 72. Hence option D is correct. This question is much better question than the previous one. Previous one was a very straight cut question which came in JEE Main 2021. But this question came in JEE Main 2022. It's a much better question. Have you understood this problem clearly? Okay, let's move for the next problem. So they are saying that the numbers are to be formed between 1000 and 3000. So it will be a 4-digit number. You have to form such 4-digit numbers which are falling between 1000 and 3000. And not only that, it has to be divisible by 4. And we have to use only the digits 1, 2, 3, 4, 5 and 6. Only these 6 digits are available to us. We have to form the 4-digit number, which is falling between 1000 and 3000 and divisible by 4. We have to find out the total number of such numbers. Now, one thing for sure, any number which is lying between 1000 and 3000, the 1000 place can be filled only by 1 or 2. Think about it. Any digit which is filling the 1000 place other than 1 and 2 in our given available digits, the number so formed will never fall between 1000 and 3000. Is it clear to everyone? Now the second question comes, that it has to be divisible by 4. Now, checking the divisibility rule for 4, can you remember? This all we have done in very childhood classes. Now we have to recall everything, because one thing I can tell you, if you go for the previous year papers, you will find in maximum questions in JEE Mains, they used to check whether we know the divisibility rule or not. That is why they used to give us the numbers so formed will be divisible by 3 or 2 or 6 or 11 or something like that. So you have to recall all those back memories. The past memories we have to recall. Now, what is the condition that any number of any digit is divisible by 4? What is the divisibility rule? The last 2 digits should be divisible by 4. If it is divisible by 4, then you will say that the whole number is divisible by 4. That's it. Is it clear? So now let us see how many numbers we can form, the last 2 digits, in how many different ways we can fill, such that this number so formed will be divisible by 4. Okay? The available numbers are 1, 2, 3, 4, 5, 6. So the numbers can be, the last 2 digits can be 12, which is divisible by 4, 13, no, 14, no, 15, 16. Then we are coming for 23, no, 24 will come, 25, no, 26, no, 34, no, 35, no, 36, yes. And then 45, no, 46, no. Okay, 56, yes. Then we have to count from the back also. 65, no. 64, yes. 63, no. 62, no. 61, no. 54, no. 53, no. 52, yes. And 51, no. 43, not possible. 42, no. 41, no. 32, yes. 31, no. 21, no. That's all. So when the last 2 places are filled by these 8 numbers, then the numbers so formed will be guaranteed divisible by 4. Are you with me? Okay. So these last 2 places can be filled by any of these 8 methods. And the 1000 place digit will be filled either by 1 or by 2. So let me consider case 1. Case 1 is the 1000 place digit is filled with 1. Let us say. Now, what are the numbers that can be written in these last 2 places? No digits will be repeated. That is, no 1 can be used in these 2 places, because 1 has already been used in the 1000 place. I cannot use it twice. So, these 2 places can be either 24, 36, 56, 64, 52 or 32. That is, we are getting 6 such ways to fill these last 2 places. Am I correct? Now, when these last two places is filled with any of these 6 ways, so we are already used 3 digits. Now we are left with only 3 digits, which can be filled in this 100 place. Therefore, total number of such numbers so formed will be 18, which are all starting with 1. That is, all the numbers are lying between 1000 and 3000, and all the numbers so formed, these 18 numbers so formed, are all divisible by 4. Okay, let us consider case 2. What is that? The first, the 1000 place is, let us say, filled with 2. Because there are only 2 possibilities. Either the 1000 place will be filled with 1 or it will be filled with 2. So when it is filled with 2, the last 2 digits can be filled. You see, 2 I cannot use anymore. So either the number will be this, or it can be this, or it can be this, because 2 I will not use, and this. That's it. So these last 2 places can be filled in 4 different ways, because these 4 digits only can come. And again, we have already, the moment I place 2 digits in the last 2 places, we have already used 2. So we are left with 3 more digits. So that 3 digits can come here in 3 different ways. Therefore, total number of such numbers so formed is 12. Is it clear? So there are 12 such numbers, 4-digit numbers, falling between 1000 and 3000. Using the digits 1, 2, 3, 4, 5 and 6, and all divisible by 4. If it starts with 1, the total number is 18. 18 such numbers are there. If it starts with 2, 12 such numbers are there. Therefore, total numbers so formed, maintaining the given condition, will be 18 plus 12. That gives us 30. And 30 is the right answer for this. Is it clear to all of you? I hope now your fundamental principle of counting is very clear to us. As well as what we have done here, we have used restricted permutation also. So these are the things which are now we are very clear. Now we will go for the meaning of nPr. Meaning of nPr. That is, you see, so far whatever maths we have done, we have all calculated manually. We have permuted. We found how many number of permutation we can do, but analytically. But now if the numbers are very big, then it is not possible for us to do it by analytical method. Yes, analytical method is a good tool, but there is also a formula available which states nPr. What is nPr? It states that it is nothing but factorial n divided by factorial n minus r. What does it mean? It means that if there are n distinct objects and r objects are to be taken at a time to permute without repetition, then the total number of such permutations will be factorial n divided by factorial n minus r, which is actually nPr. And one thing we must remember, this is the condition, that your r is always less than equals to n. And one condition we must always remember, that your r is always less than equals to n. And it's quite obvious, because the number of things that you are permuting cannot be more than the numbers which is available. In this case, the available number is n distinct objects. So your selection, the total number of ways of permuting the numbers cannot be more than n. Is it clear? So that is why your r is less than equals to n. Okay? We all know that factorial 0 is 1. This we have already covered in factorial notation thing. Right? Okay. So let us just take some problems based mainly on this application of this formula. See this question. The question states that 56p r plus 6. Achha, let me just calculate one by one. What is the definition? 56 factorial divided by, so it's coming to okay. And what is your 54pr plus 3? That gives us so it's 54 factorial divided by 51 minus r factorial. Correct? Now they have given the ratio. They have given the ratio. So if I take the ratio, we are going to have in the left hand side as 56 factorial by into 51 minus r factorial divided by 54 factorial, which is equals to 30800. So now 56 factorial can be written as 56 into 55 into 54 factorial, and 51 minus r can be written as 51 minus r into 50 minus r factorial divided by 50 minus r factorial into 54 factorial. That gives us 30800. Now this and this goes off. This goes off. So we are left with 51 minus r equals to 30800 divided by 56 into 55, which gives us actually 3080, right? So if we cancel this, we are having 10. So that implies 51 minus r is basically 10, implies your r is 41. Correct? It is simply the application of the formula. No big thing is involved in it. So now we have to find out what is the value of rp3, which is actually 41p3. So according to the formula again, 41 factorial divided by 41 minus 3 factorial, that gives us 41 factorial by 38 factorial. So 41 factorial can be written as 41 into 40 into 39 into 38 factorial divided by 38 factorial. So that gives us 41 into 40 into 39. So the answer will be 41 into 40, that gives us 1640 into 39, that gives us 63960. Is it clear? So that's our required answer. Is it clear to everyone? Okay, let me take the next problem. The question is, if x plus y p2 is 90, let me do one by one. It is given that x plus y p2 is 90. So according to the definition, it is x plus y factorial divided by x plus y minus 2 factorial, which is equals to 90. So x plus y factorial can be written as x plus y minus 1, x plus y minus 2 factorial divided by x plus y minus 2 factorial, which is equals to 90. So this goes off. So we are left with x plus y minus 1 is 90. Let me just take x plus y as a for a time being. Okay? Now, one thing you must remember, that your a is definitely greater than 0. Because in nPr, your n cannot be less than or equals to 0. It cannot be. Okay? So your a is greater than 0. So the expression becomes a square minus a minus 90 is 0. So that gives us a minus 10 into a plus 9 is 0. That implies either a is 10 or a is minus 9. Now minus 9 is not possible as a is greater than 0. Therefore we are having from here a equals to 10, implies we are having x plus y is 10. We are having x plus y as 10. Now, the second condition which is given to us is x minus y p2 is 30. So again, let me use the formula x minus y factorial divided by, which is 30. So that gives us x minus y minus 1, x minus y minus 2 factorial divided by x minus y minus 2 factorial, which is equals to 30. So this 2 goes off. So we are having x minus y into x minus y minus 1 is 30. Let us say x minus y is b. Again, your x minus y is again greater than 0, right? It cannot be less than or equals to 0. I have already explained that. So it is basically b into b minus 1 is 30 gives us b square minus b minus 30 is 0. And if we factorize, we are going to have b minus 6, b plus 5 equals to 0. So from here we can write either my b is 6 or b is minus 5. Again, minus 5 I cannot take because b is greater than 0. Therefore, we got that x minus y is nothing but 6. Okay? So we got x plus y as 10 and x minus y as 6. Now we have to find out x and y. So let me just add this 2. We are getting 16 implies x is 8. And if we subtract, we are getting 2 times y is 4 implies y is 2. Therefore, the value of x will be 8 and the value of y will be 2. Is this sum clear to all? See, this sum are what? This sum are simply application of nPr. That's it. I hope you are now clear to this application of nPr, right? Okay, so let us move for the next problem. So this question, we have to prove that this thing which is given to us, let us consider the left hand side. Now, whenever this kind of problem comes, I think you people have remembered what memory it used to strike in our brain. Sequence and series. It's basically a question from sequence and series, like that. So how we have done in that case? We used to find out the nth term and we write the nth term in such a way that it forms the telescopic, form. And we use the telescopic method to find out its sum. Exactly the same thing I will do it here. Please see the left hand side. What is the nth term? It is n into npn. What is npn? It is factorial n divided by n minus n factorial. That gives us what? Factorial 0. And we all know that factorial 0 is 1. So it is coming to n into n factorial. Now this n can be written as n plus 1 minus 1 into factorial n, which can also be written as n plus 1 into factorial n minus factorial n. Now this thing can be written as n plus 1 factorial minus n factorial. Is it clear? So that is our nth term. So see, the telescopic form has already occurred. Now what is our task? Simply to put 1, 2, 3, 4 till n in place of n. That's it. And we will add up. So what is our T1? It's factorial 2 minus factorial 1. What is T2? It is factorial 3 minus factorial 2. What is T3? Factorial 4 minus factorial 3. And this thing goes on. So Tn will be n plus 1 factorial minus n factorial. Is it clear? Now let me just add the corresponding sides. So in the left hand side you are going to have LHS. If you add T1 plus T2 plus T3 till Tn, it is nothing but your left hand side. Isn't it so? Because this is the first term, this is the second term, this is the third term, and this is the nth term. So if you add up, you are going to have the left hand side directly. And in the right hand side, you see these terms gets cancelled. So ultimately in the right hand side we will be left with n plus 1 factorial minus 1 factorial, which is same as 1. Now n plus 1 factorial can be written as n plus 1 p n plus 1, isn't it so? N plus 1 p n plus 1 means what? It's n plus 1 factorial divided by n plus 1 minus n plus 1. Okay? Factorial. So that gives us basically n plus 1 factorial divided by factorial 0. That gives us n plus 1 factorial only. So the right hand side has come. So we have proved the left hand side equals to right hand side. Is it clear? So nPr, application of this formula, is clear to us? Okay. So in this part of the permutation, we are going to discuss about restricted permutation. What is that? It is actually the permutation. But here some restrictions will be given to us. Is it clear? Like anything. Suppose if I take a word and they will say the restriction is, it will start with this, it will end with this. I mean, all sort of restrictions will be given in the question. And there, maintaining all these conditions, we have to permute the things. That is why the name restricted permutation. So let me take an example. See this question. Total number of words that can be formed using all the letters of the word education. E-D-U-C-A-T-I-O-N. Now what are the vowels? Let me just write the vowels first. A is there. E-I-O-U. All the vowels are here. Okay. And what are the consonants? There are D, C, T and N, right? Total there are 9 alphabets. Okay, so now let us read the first question. The question is, the condition is given that there is no repetition is happening in any of the cases given in this 7 problems. So no repetition is allowed. The first question is, in how many different ways the words can be formed when there is no restriction? So it's pretty simple, since there are 9 alphabets, so they can arrange among themselves in 9 factorial, which is same as your 9p9. Am I correct? There are 9 distinct alphabets, out of which you are permuting, taking 9 at a time. So what is the formula that I have used? I have used 9p9, which is same as your factorial 9. Is it clear? The second question is, relative order of vowels and consonants remain same. Now what do you mean by that? Relative order of vowels and consonants remain same. It means what? It means that wherever the vowels and consonants are there, consonants and vowels can interchange among themselves. I mean, vowels can interchange among themselves in the places where they are situated. Are you getting my point? The position where your vowels are there, vowels can come to that place. That is, all the vowels can interchange their position, but it will not take the position of the consonants. Same thing with the consonant. The positions where the consonants are, all the alphabets can arrange among themselves. I mean, all the consonants will arrange among themselves in those positions only. It will not take the position where vowels are there. This is what is called your relative position of vowels and consonants. So, we have to see in the word education, the vowels are at this place. So this is the first place, this is the third, 5th, 7th, and 8th. So in this 5 places, vowels can interchange among themselves. So that can be done in factorial 5 different ways. And the consonants are at the place 2nd, 4th, 6th, and 9th place. So the 4 consonants, they can arrange among themselves in these 4 places without disturbing the position of the vowels. So that can be done in factorial 4 ways. Is it clear? So the relative order of vowels and consonants remains same. The total number of such words formed is factorial 5 into factorial 4. I hope this conception is very clear. You have understood what is the relative position of vowels and consonants means. Is it clear? Okay, let us see question number 3. It states that how many number of words are there which will all start with I. That is, you fixed your I in the first position and now you are having 1, 2, 3, 4, 5, 6, 7, 8. So we are having 8 places and we are having 8 alphabets. All will start from I. That is the reason why I have fixed I in the first position. Getting my point? These are called restricted permutation because restriction is given. I don't want to find out how many number of words are formed. I want to find out those words which starts with I. Right? This is the restriction. So the 8 places can be filled by 8 alphabets in 8 different ways, which is nothing but your factorial 8. Clear to all? Now, the 4th question. Words end with a vowel. I have to form words which are ending with a vowel. Now, see one thing. These are the 9 places. So here you have to adjust, you have to arrange all the 9 alphabets that we are having. But we are having 5 vowels here. We are having 5 vowels here. So either of this one vowel will come at the end place of that word. Because what is the question? Vowel occupies, words end with a vowel. So this place will be filled by any of this one vowel. So this place, the last place can be filled by any of these 5 vowels. So this place can be filled in 5 different ways. Is it clear to all? The last place has to be filled by a vowel. Then only your word will end with a vowel. We are having 5 vowels. So the last place can be filled in 5 different ways because we are having 5 vowels. Any of this vowel will come at that last position. Clear? Now, again, we are now having what? 8 alphabets remaining because one alphabet has already occupied the last place. So we are having 8 alphabets in our hand. So these 8 alphabets can be arranged in these 8 places in 8 different ways, which is same as your factorial 8. Yes or no? Therefore, how many number of words end with a vowel? It will be factorial 8 into 5. Why I have multiplied with 5? Because the last place can be filled in 5 different ways. Is it clear to everyone? Vowel occupies even places. What do they mean by this? That is, your vowels can come in the 2nd place, or it can come in the 4th place, or it can come in the 6th place, or it can come in the 8th place. So in education, we are actually having 9 alphabets. So we are having 4 even places. That is 2nd, 4th, 6th and 8th. So your vowels will definitely come in these 4 places. Try to understand. Whatever word you form, the vowels will always come in these 4 places: 2nd, 4th, 6th and 8th. Okay? So the total number of ways that such words can be formed is that we are having 4 even places, and these 4 even places will be filled by either of these 5 vowels. So that can be arranged in 5p4 different ways. 5 vowels we are having, and now I have to place 4 vowels in these 4 even places. So that can be done in 5p4 different ways. Is it clear? And we are left with 4 vowels already gone. Out of the 7 alphabets, out of 9 alphabets, 4 alphabets already gone. So we are left with 5 alphabets, and we are left with 5 places. So these 5 alphabets can be arranged in these 5 places in how many different ways? It will be arranged in 5 different ways, or you can say only factorial 5 different ways. That's it. Is it clear to everyone? Is this question clear? Absolutely? Okay. So now let's move for the next problem, where they are saying that the vowels are always together. What do you mean by that? That whatever word is formed, your vowels will be always together. So what I will do here, I will take all those 5 vowels in one box, and I will consider that box as one alphabet. Is it clear? So what I'm going to do is, I am taking all those vowels in one box, A, E, I, O, U, and I'm treating this thing as my one alphabet. And we are left with 4 consonants D, C, T, N. Therefore, we are actually having 5 alphabets in our hand. One is all those vowels taken together. That is my one alphabet, and the other 4 consonants. So total 5 alphabets are there. Now these 5 alphabets can arrange among themselves in 5 different ways, or you can say in factorial 5 different ways. Now the vowels which are in one box, they can also arrange among themselves in every arrangement in factorial 5. Are you getting my point? In every arrangement of those alphabets, of those 5 alphabets, the 5 consonants, 5 vowels, they can arrange among themselves in factorial 5 different ways. So the total number of words that can be formed where all the vowels are together is factorial 5 into factorial 5. Why this factorial 5 is coming? Because we are having 5 alphabets, taken all the vowels as one alphabet and the other 4 consonants. So we are having 5 alphabets. They can arrange among themselves in factorial 5 ways. And the 5 vowels, they can arrange among themselves in factorial 5 ways. And that is the reason why I have multiplied with factorial 5. Is it clear? So vowels are always together. It will be factorial 5 into factorial 5. Now the last part of this question is that consonants are always together. So now they are not talking about the vowels. They are saying that the consonants will be together. Same method. I will take all those consonants. D, C, T, N in one box. And I will treat this box as my one alphabet. And other we are having 5 vowels. In this case, we don't have any restriction on vowels. We have only restriction on the consonants. So we are having 6 alphabets now. That is 5 vowels and 1 box. Box means all the consonants are in that box. So these 6 alphabets can arrange among themselves in factorial 6 different ways. And for every arrangement of this factorial 6, your 4 consonants, they can arrange among themselves in factorial 4 different ways. So the total number of words that can be formed where all the consonants are together will be factorial 6 into factorial 4. Have you understood why I have multiplied with factorial 4? Because there are 4 consonants. So they can arrange among themselves in every arrangement. So the total number of arrangement will be, as we are having 6 alphabets altogether, taking those 4 consonants as one alphabet. So they can arrange among themselves in factorial 6 ways. And 4 consonants can arrange among themselves in factorial 4 different ways. So total number of words that can be formed where all the consonants are together is basically factorial 6 into factorial 4. That's it. Is it clear to everyone? Let me take another example. See this question which came in JEE Main 2021. They're saying that the number of 6-letter words formed using all the letters of the words vowel. Here the restriction is that all the consonants will never come together. So in vowels, we are having how many number of vowels? We are having 2 vowels, O and E. And we are having consonants like V, W, L and S. The question is, the consonants, all the consonants never come together. Now, very important, in permutation combination, you have to understand the word that they have said, what they are actually saying. Understand this problem. They are saying that all consonants never come together. All consonants. That is, they are saying if 3 consonants are together, I don't mind. If 2 consonants are together, I don't mind. But I will mind when all those 4 consonants are coming together. Are you getting my point? Are you getting the question? These 4 consonants should not be together. If 2, 3 consonants are together, I don't mind. There is no restriction where they have said that no, 2 consonants will never be together. No. I want those words which can be formed where all the consonants are not together. All the consonants are not together. So what I will do here, I will simply find out how many ways vowels can be arranged among themselves without any restriction. So there are 6 alphabets. So vowels can be arranged among themselves in factorial 6 different ways. Without any restriction. No restriction is given. By taking all the alphabets of the word vowels, if you arrange, the total number of words that will be formed is factorial 6, which is nothing but your 720. Okay? Now, think about it. So in this question, what I will do, I will first find out how many number of words are forming in which all the consonants are together. We will find out how many number of words are forming when all the consonants are together. Then what we will do? We will subtract those numbers from the total number of words that can be formed without any restriction. Clear? So when 4 consonants are together, keep these 4 consonants in one box and take this thing as one alphabet. So we are left with 2 other alphabets. So these 3 alphabets can arrange among themselves in factorial 3 different ways. But in every arrangement, these 4 consonants can arrange among themselves in factorial 4 different ways. So total number of words with or without meaning that can be formed where all the consonants are together is factorial 3 into factorial 4. That gives us so it is 144. Therefore, total number of words that can be formed when all consonants all consonants never come together will be 720 minus 144, and that gives us 576. Am I correct? Hence option A is correct. Is it clear to all? Have you understood this problem clearly? Okay, so let's move for the next problem. See this question. In this question, they have said that there are 5 boys and 5 girls are to be arranged in a line such that the first question is all girls are together. All girls are together. So what I will do, I will take those all 5 girls, let us say G1, G2, G3, G4 and G5. All those 5 girls I will consider in one box, and I will consider this box as my one element or one object. And there are 5 boys, let us say B1, B2, B3, B4 and B5. Now we are having 6 objects in our hand. One is this box, another one 5 boys. So these 6 objects can be arranged among themselves in 6p6 different ways, or we can write this thing as factorial 6 different ways. Now, in every arrangement of this factorial 6, these 5 girls who are sitting together can arrange among themselves in factorial 5 different ways. Therefore, the total number of ways when all the girls are together will be factorial 6 into factorial 5. Is this question clear? 5 girls should be together. So I am taking these 5 girls as my one object. So I kept that 5 girls in one box. So we are having now 5 boys and one box. Box means that consisting of 6 girls. 5 girls. So now we are having 6 objects in our hand. So these 6 objects can arrange among themselves in factorial 6 different ways. Now in every arrangement of this factorial 6, the 5 girls can arrange among themselves in factorial 5 ways. Therefore, the total number of ways in which all girls will be together is factorial 6 into factorial 5. Is it clear? Let's move for the next one. All boys and all girls are together. So what I will do, now I have made those 5 girls I have taken in one box, and now I will take these 5 boys in one box. So now we are having only 2 objects. So these 2 objects can arrange among themselves in factorial 2 different ways. And in every arrangement of this factorial 2, the 5 girls can arrange among themselves in factorial 5 different ways, and 5 boys can be arranged among themselves in factorial 5 different ways. So total number of ways in which all boys and all girls are together will be factorial 2 into factorial 5 into factorial 5. Is it clear? What I have done in this case, they have said that all boys will be together and all girls will be together. So I made the 5 girls in one box and 5 boys in another box. So now we are having 2 boxes, means we are having 2 elements. So these 2 elements can arrange among themselves in factorial 2 different ways. Now in every arrangement, 5 boys can interchange among themselves in factorial 5 ways, and 5 girls can arrange among themselves in factorial 5 ways. So total number of ways in which all these 5 girls and all these 5 boys will be together is factorial 2 into factorial 5 into factorial 5. Is it clear? Okay. Now, all girls are not together. Very important question. All girls are not together. What they are saying about? They are saying that all those 5 girls will not be together. All these 5 girls will be not together. That is, if 2 girls are together, accepted. 3 girls are together, accepted. 4 girls are together, accepted. But all 5 girls will never be together. Is it clear? So what I will do in this case, first I will consider that without any restriction in how many different ways this 5 boys and 5 girls, that is total 10 objects I will take. I will take every boy and every girl as an object. So total 10 objects can arrange among themselves in factorial 10 different ways. Now this is without restriction. These 5 boys and 5 girls are arranging among themselves. Now I will consider that all those 5 girls are together. If all the 5 girls are together, total number of ways in which all the 5 girls will be together is factorial 6 into factorial 5. Therefore, total number of ways in which all girls are not together will be factorial 10 minus factorial 6 into factorial 5. Is it clear? I'm not going for the calculation. Calculation you can do. My main motto is to make you understand the logic. Now, what is the logic here? They are saying that 5 girls will not be together. So what I have done without any restriction in how many different ways they can sit. So they can sit in factorial 10 different ways. Now I've already in fact calculated that if the 5 girls are together, what will be the total number of ways? And that is factorial 6 into factorial 5. So what is the total number of ways in which not all the girls are together? It will be factorial 10 minus factorial 6 into factorial 5. That's it. Now in this case, that is whatever answer we got, factorial 10 minus factorial 6 into factorial 5. In this total number of ways, all girls will not be together. But there are cases when 4 girls are together. There are also cases when 3 girls are together. I don't mind for that. This is the total number of ways when all girls are not together. Are you getting my point? Okay. See the next question and first try to understand the difference between the third and the fourth question. Here the question is, no 2 girls are together. No 2 girls are together. Is it clear? So what to do? See, in this case, you don't have any problem with the boys. So what I will do, I will simply put those 5 boys, keeping one seat vacant in between 2 boys. So how I will place the boys first? Let me say boy 1 is here, boy 2 is here, boy 3 is here, boy 4 is here, and boy 5 is here. So now we are actually having 6 seats in between the boys. Now think about it. If I put the girls in those 6 places, will ever 2 girls will be together? No. Is it clear? No. No 2 girls will be together if we place those 5 girls in those 6 places. This method is what called your gap method. You have to remember it's a very important method. This method is what called your gap method. So 5 boys can be arranged in these 5 places, in how many different ways? They can arrange in these 5 places in factorial 5 different ways. Am I correct? 5 boys can arrange among themselves in factorial 5 different ways. Now there are 6 places in between. So in these 6 places, if we place 5 girls, then the 2 girls will never be together. And in these 6 places, 5 girls can be put in how many different ways? it will be 6p5 different ways. Is it correct? So 6p5 actually indicates in how many different ways your sixth place will be permuted by taking 5 objects at a time. That is, in this 6 seats, I am placing all those 5 girls. In how many different ways that can be done is represented by 6p5. So total number of ways in which no 2 girls are together, because your girl can come here, it can come here, it can come here, it can come here, it can come here. But no problem, you see, in this case, no 2 girls are together. Am I correct? No 2 girls are together. So total number of ways when no 2 girls are together will be factorial 5 into 6p5. Okay? Again, calculation you can do it by yourself. It's pretty simple. 120 into 720 it will give us, because 6p5 is basically 720. So multiply and get the answer. But have you understood the logic behind it? Absolutely. This method is very important. This is what is called your gap method. Okay, move to the next question. Boys and girls are alternate. Boys and girls are alternate. Now, what is the difference between this question, question number 5, and question number 4? The difference is that in the first case, in question number 4, I have said that no 2 girls are together. And in the 5th question, I am saying that boys and girls are alternate. So somebody can think, said these 2 questions are same. No, it is not same. I am showing you why. Suppose in the 4th case, let me consider one case like this. Here G1, B1, G2, B2, G3, B3, G4, B4, and G5, B5. So this is one arrangement when no 2 girls are together. Now this arrangement is same as boys and girls are sitting alternately. Yes or no? Which is actually your question number 5. But see, in question number 4, there is also an option when your see this option. See this option. This option is basically one option of question number 4. Here, no 2 girls are together. That's okay. But have you observed one thing? Have you observed one thing? That these 2 boys, in this arrangement, these 2 boys are now side by side. So 2 boys are now coming, they are sitting together. But what is our condition in question 5? That boys and girls should sit alternately. That is the difference between question number 4 and question number 5. Your question number 5, whatever answer we will get, all those cases are already involved in question 4. But there are some other ways also which are involved in question 4 which I don't want. And this is one of the cases that I have shown you. Have you understood the difference between question 4 and question 5? Very important. Until and unless you understand those words, until and unless you understand the meaning of the question, what actually examiners want to check whether you know it or not, that's very important to identify first. So in this case, boys and girls are alternate. So what I will do, I will consider here that first, let me just place all those boys. So I have placed these 5 boys in 5 places, again, keeping 1 seat vacant in between. Okay? So there will be 6 such sets. But in this case, when we are placing the girls, we should be very careful. We should first consider that one case will be when girl 1 is coming here, the other girl is coming here, the third girl is coming, let us say here, this is say G4, this is say G5. No one will occupy this set when one seat being occupied by the beginning of, in the right side of B1. When that place is occupied, you cannot occupy this place by any other girl. Why? Then two boys will be side by side in that case. Are you getting my point? So this is one option. This is my case 1 when your boys and girls, they're sitting alternately. This is case 1. And what is case 2? Case 2 is your boy 1 is here, boy 2 is here, boy 3 is here. I'm not disturbing boys because they are sitting in this place. Now, girls will come here, 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 and here. So this is another case. That is your first place, that is the right side of B1 is vacant. So these are the two cases which we have to consider when boys and girls are sitting alternately. Is it clear? So the first place can be, the first case can be accomplished in factorial 5 different ways. Why factorial 5? Because 5 boys can arrange among themselves in these 5 places in factorial 5 different ways. And 5 girls can arrange among themselves in the places that we have fixed for the 5 girls in factorial 5 different ways. Is it clear? So this is the total number of ways in which the boys and girls will be alternately sitting in case 1. In case 2, the same thing is going to happen. So total number of ways when your boys and girls are sitting alternately is 2 times factorial 5 into factorial 5. Am I correct or not? So first thing is that you have to understand the difference between when they are saying that no 2 girls are sitting together and the question boys and girls are sitting alternately. First you have to differentiate between these 2 questions and then you have to follow the thing that I have told you right now, as well as I've given you the proper explanation by virtue of which you can distinguish what is the difference between question number 4 and 5. Okay, let's see question number 6. What they're saying? Now it's a very typical thing. Boys and girls are alternate. Boys and girls, they are alternate. And the total number of ways is 2 times factorial 5 whole square. This is what? When boys and girls are sitting alternately. Now there is another condition given. That is, one particular boy and one particular girl, these 2 people will not sit together. Getting my point? So what I'm doing is, I'm taking this particular boy, let us say that is B1, and particular girl, let us say G1. We are taking these 2 as my one unit. Let me denote this thing by X. Now what I'm trying to do is basically, I want to find out the number of ways when the boys and girls are sitting alternately and at the same time, we are finding out the total number of ways when B1 and G1 will be together. And if we subtract that number from the total number of ways when the boys and girls are sitting alternately, which is 2 into factorial 5 whole square, then we are going to get the number in which the boys and girls are sitting alternately, but B1 and G1 are not together. Is it clear? Is this question clear to everyone? Well, so now as we have separated the particular boy and girl, so we are left with 4 boys, B2, B3, B4 and B5. Along with that, we are having 4 girls left, G2, G3, G4 and G5. Let me just go in the next page. Now let us try to find out in how many different ways these boys and girls can sit alternately. First, let me just put the boys keeping one seat vacant in between. And let us assume that the girls are coming only to these places. That is G2, G3, G4 and G5 are coming here. Now let me take another case also when boys are sitting in this way. When boys are sitting in this way, but the girls are sitting here, and this place. Okay, we will take these two cases separately. Now, when this thing, the arrangement is this, when the arrangement is this, the boys can arrange among themselves in factorial 4 different ways. The girls can arrange among themselves in factorial 4 different ways. Now, we are having the unit X, which they have seated in the way B1, G1. Now we have to place this unit X in between this first arrangement. Now where to put and how to put it so that the boys and girls alternate condition is maintained. Now look it very carefully. If I put this unit X in somewhere in between this point or this point or this point or this point, in these 4 places, if we put this unit B1 and G1, when B1 and G1 are seated in this fashion, then there are 4 such ways in which the X can be placed. You see, your X cannot be placed other than these 4 points in the first case. Otherwise, what will happen? The alternate boys and girls will be not there. So these are the only 4 possible places where this X can be placed when in that X, B1 and G1 are sitting in this fashion. Is it clear to all of you? Is this clear to all of you? Absolutely. Okay. Now if G1 and B1 interchanges their place in this way. Now this arrangement, when the arrangement of girl 1 and boy 1 is in this fashion, they can be placed to maintain the same condition that alternately boys and girls are sitting. They can be seated either in this place or this or this or this or this place. Tell me yes or no. In that case, your alternate boys and girls, this condition is still valid in this case. Yes or no? So the number of ways in which this X can be placed is total 9 ways. So the total number of ways will become factorial 4 into factorial 4 into 9. Is it clear to all of you? I have considered that girls are sitting first in the row and then boy, then girl, then boy, and this thing goes on for these 4 people. So now this is the arrangement where the boys and girls are sitting alternately. Now I have to place this X. What is X? Now X is that box where your B1 and G1 are sitting together. So now if the arrangement is B1 and then G1, then you can place this X in the 4 places. And if the arrangement is G1 and B1, then you can put it in 5 more places. Okay? To maintain the predetermined condition that the boys and girls will be alternate. So there are total 9 ways in this case. Is it clear? Let us consider the second case. In the second case also, look at very carefully. The boys can sit in factorial 4 different ways. The girls can sit in factorial 4 different ways. And now, if the arrangement of X is like B1, G1, if they are sitting in this way, B1 and G1. So they can be placed either here or here, this one, this place or this place. So there are 5 such places where this X can be placed, such that again the boy, girl, this alternate condition will be valid. Clear? Now if this boy 1 and girl 1, they interchange their places, so this arrangement, this is also your X, so this arrangement can be placed in the second case where it can be either placed at this place or at this place or at this place or at this place. So there are again 4 such places where if G1 and B1 sits in the second fashion, they can be seated. So that again I'm mentioning the alternate boy girl, this condition is maintained. Is it clear? Again we are having 9 such places where your X can be placed. So total number of ways will be factorial 4 into factorial 4 into 9. Therefore total number of ways in which the students are, the boys and girls are in alternate position, as well as B1 and G1 are sitting together, is factorial 4 into factorial 4 into 9 into 2. Right? Because I have simply added this and this. So this is the total number of ways when the boys and girls are alternate and B1, G1 are sitting together. Now we got in the previous slide, we have shown that when the when the boys and girls are sitting in the alternate way, the total number of ways was 2 into factorial 5 whole square. So if I subtract this, the calculation we got from in our case, so this will be the total number of ways. This will be the total number of ways when the boys and girls are sitting alternately. But B1 and G1, they are not together. Is it clear or not? Again I'm telling you, again I'm revising, this sum is little bit critical. What I'm doing is, the question is the boys and girls will sit alternately and at the same time your B1, G1 should not sit together. So what I have done, I have first calculated the total number of ways where the boys, 5 boys and 5 girls are sitting alternately. That is 2 into factorial 5 whole square. That we have already done in the previous part of the sum. Now what we are doing, we are calculating the total number of ways in which the boys and girls are sitting alternately. At the same time, B1, G1 are sitting together. And then we are subtracting this value from the previous one to get the total number of ways in which boys and girls will be alternate, but B1, G1 will never be together. Is it clear now? Therefore, our answer is 2 into factorial 5 whole square minus factorial 4 into factorial 4 into 2 into 9, I think, yeah. So 2 into 9, and that will be the answer. Calculation I'm not focusing on. You can do this calculation by yourself. So that will be our final answer for question number 6 of this question. Is this part clear to all of us? Absolutely. Okay, now let us move for the next conception. So now we will learn how to permute objects not all distinct. So far what we have learned, in all the numbers or all the words that has been given to us, the numbers and digits were different. But now, if in any word, if we find that words, all the alphabets in the words are not different, some of them are alike, in that case, how to permute those words? Let me take an example. Suppose we are having A, B, C. These 3 are distinct alphabets, Now, if I ask you, in how many different ways these three alphabets can be arranged to form words? So what will be your answer? Your answer will be factorial 3. Am I correct? Means, what are those? It is actually 6 words we will form. What are those? ABC, ACB, BCA, BAC, CAB and CBA. Am I right? So we got 6 different words formed by these 3 alphabets which are all distinct in this word ABC. Now suppose if we have the alphabets in the word as AAB. Now in how many different ways we can form words with or without meaning? Though this word itself doesn't have any meaning, right? But anyways, in how many different ways we can form word from these 2 identical alphabets A and 1B? So it will be what? Either it can be AAB, or it can be ABA, or it can be BAA. So only there are 3 words that can be formed by taking all the alphabets of the word A, A and B. Am I correct or not? So when 3 alphabets all are distinct, then we are having factorial 3, that is 6 words are forming. But when we find that the 2 alphabets of the given word are identical, in that case we are having only 3 words. Why this thing is happening? It's because your 2 A's are identical. That's the only reason why this is happening. So how to get the answer? Here the alphabets are only A and B. So we are having only 3 alphabet word. So that is why we can see it mathematically. But how we will understand, or how we will know that how many different words will be formed when a big letter is given? A big word is given in which say 3-4 terms are identical. So in that case, how to do it? See the computer screen. In this case, for a time being, we will assume that this A and B all are distinct. If they are all distinct, then the total number of words that can be formed is factorial 3. But actually we are getting only 3 words. So in this case what we will do, since we are having 2 A's identical, so I will simply divide this result by factorial 2, and you see we are getting the answer as 3. That is, there are 3 different words that can be formed by taking all the alphabets of the word A and B. Am I correct or not? So what we have learned is that if suppose a word is given which consists of say 3 A's and 2 B's. Now if I ask you how many different words you can form by taking all those 5 alphabets, and your answer in that case will be, first you will assume that all those alphabets are different. So there will be 5, there are 5 alphabets. So first you write factorial 5. And since 3 A's are identical, you divide it by factorial 3, and 2 B's are identical, so you divide again by factorial 2, and this will be the total number of words that is formed. Am I clear or not? So here we will have 10 different words that will be formed when in this 5 alphabets your 3 A's and 2 B's are identical. Have you understood how to permute objects when they are identical? Okay, so let me take an example. See this question. The number of words with or without meaning that can be formed using all the alphabets of the word IIT JEE. What I will assume first, all the 6 alphabets in this word are different. So there are 6 alphabets. So it will be factorial 6 divided by, we are having 2 i's identical, so divide by factorial 2, and we are having 2 e's identical, so again divided by factorial 2. So the total number of words that can be formed with or without meaning is 720 divided by 2 into 2. That gives us 180. Am I correct? Have you understood this? So what we have learned that if we find that there are n objects, and out of which, let us say, P are alike, Q are alike of another kind, P are alike of one kind, and say R are alike of another kind. Then total number of permutations taking all the elements of all the objects of the given objects will be factorial n divided by factorial p into factorial q into factorial r. That's it. So this is the total number of arrangements of n objects out of which p are alike of one kind, q are alike of another kind, and r are alike of another kind. Is it clear to all of you? Okay, so let me take another problem of this kind. This we have already done. Say this question. This is a question of restricted permutation when objects are not all distinct. The question is number of words. This is words actually. Number of words with or without meaning that can be formed using all the letters of the word Mississippi. Now here we can see that we are having 4 S, 2 P's, 4 I's. Yes? And the other alphabets are only M. Okay? We are having 4 I's, 4 S, 2 P's and 1 M. So here, all the alphabets of the word given Mississippi are not distinct. There are 4 I's, there are 4 A's and there are 2 P's. So they are identical. So now let's see the question. The question is, how many words you can form which will start and end with I? Okay? So how many alphabets are there in this word Mississippi? We are having 4, 4, 8, 10, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, right? Now, what they have said, it will start and end with I. So let me just fix 2 I's here. Is it clear? So now your 2 I's are fixed at 2 extreme points. Now we are left with 4 A's, 2 P's and 2 I's and 1 M. In how many different ways all these 9 places can be arranged? It will be arranged in factorial 9 because these 2 I's are not interchanging their place. Even if they interchange, they are the same thing. Why? Because both are identical. Therefore, we are left with 9 alphabets. So these 9 alphabets are arranged among themselves in factorial 9 divided by factorial 4 into factorial 2 into factorial 2. Am I correct? This factorial 4 is for 4s. This factorial 2 is for 2p's. And this factorial 2 is for 2 i's, because already 2i has been fixed in the 2 extreme points. So we are left with only 2 identical i's. Therefore, the total number of ways will be factorial 9. Don't calculate this because this will be a huge number. So the total number of ways, total number of words that can be formed with or without meaning when 2 i's are fixed at the start and the end point of every word is factorial 9 divided by factorial 4 into factorial 2 into factorial 2. Okay, next point is ends with a constants. So how many different words you can form when it ends with a constant? Now in the word Mississippi, how many number of vowels you have? We have only 4 vowels which are 4 i's. Right? So we are left with 7 consonants. Here are 4 vowels and 7 consonants. Now the question is, how many words you can form which will end with a consonant? Okay? So out of these 7 consonants, any consonant can come in the last place. Okay? So this place will be filled with by any consonant. Now consonants are either S, P or M. So we are basically having 3 consonants. So this last place can be filled in 3 different ways. The last place can be filled in 3 different ways because I have to fix it with a consonant. Clear? Now let us assume, here we have to consider some cases. Let us assume case 1, that the last place is being filled with M. So what are the alphabets that are remaining for us to arrange in these 10 places? We are having 4 A's, 2 P's and 4 I's. So they can arrange among themselves in factorial 10 divided by factorial 4 into factorial 2 into factorial 4. Am I correct? Now, case 2. Let us say the last place is being filled with the consonant S. This place is filled with the consonant S. So if it is filled with consonant S, then what are the remaining alphabets we are having in our hand to arrange in these 10 places? We are having 3 S, 2 P's, 4 I and 1 M. Is it clear? So it can be arranged when the last place is filled with 3, it can be arranged in factorial 10 divided by factorial 3 for 3s, factorial 2 for 2 p's and factorial 4 for 4 i's. So this is your case 2. When the last place is filled with the alphabet S. Is it clear? Now case 3, the last case I will take. This place, let us say now, it has been filled with the other consonant which is P. Now if 1 P goes, we are left with only 1 P, 4 A's are available, 4 I's are available and 1 M is available. So the rest 10 places can be filled by factorial 10 divided by factorial 4. This is for 4s. Factorial 4 again for 4 i's. Is it clear? We are having 1 p and 1 m. So no need to divide it. So this is factorial 10 divided by factorial 4 into factorial 4 is the total number of ways when the last place is filled with the consonant P. Therefore, total number of ways in which the words will end with a consonant is either this the first case or the second case or the third case. That's it. So that will be your final answer. Simply by adding case 1 plus case 2 plus case 3. That's it. Is it clear to all? Absolutely? Okay. So now let us move for the third one. What they have said? All vowels are together. That is, what they are actually saying is you keep all those vowels in one place. They will be always together. Okay, so let us do one thing. Let me just keep all those 4 I's in one box and treat that thing as your one alphabet. So 4 I's are there and we are having 4 A's. We are having 4 A's. We are having 2 P's and we are having 1 M. Now, in how many different ways, how many number of alphabets now we have? We will treat these 4 I's as one alphabet because they will be always together. So total alphabet will be 1, 4, 1, 5. Total there are 8 alphabets now. This is your first one alphabet. These are the 4 alphabets, 2 and 1. So there are 8 alphabets. Now these 8 alphabets can arrange among themselves in factorial 8 divided by, since there are 4 A's identical, so it will be divided by factorial 4 into divided by factorial 2 because of 2 P's. But I will not divide this thing by factorial 4 for 4 I's. Can you tell me why? Because this 4 I is always together. They are not arranging in this permutation. They are always together. We have taken that thing as one alphabet. So even if they interchange in between, it will remain identical because 4 I's are identical. Getting my point? So total number of words that can be formed where all the vowels will be together is factorial 8 divided by factorial 4 into factorial 2. I hope you have understood this. Okay, now let us come for the fourth one, which is all consonants are together. Now what are the consonants? The consonants are 4 A's, 2 P's and 1 M. Okay, and 4 I's are separated. These consonants will be always together. Clear? Now, let me consider these whole consonants as my one alphabet. Let me consider these whole consonants as my one alphabet. So if this is one alphabet, we are actually having 5 alphabets. So they can arrange among themselves in factorial 5 different ways. And since 4 I's are identical, so they can arrange among themselves in, it has to be, since they're identical, it has to be divided by factorial 4. Tell me yes or no. Now, inside the box, there are 4 A's, 2 P's and 1 M. They can arrange among themselves. Now, they can arrange among themselves in factorial 7 because there are 7 alphabets, out of which 4 A's are identical, so it has to be divided by factorial 4. 2 P's are identical, so it has to be divided by factorial 2 at the same time. Tell me yes or no. What I have done, I have simply kept all the consonants in one box. And we have left the vowels outside that box, which is only 4 I's. Now, taking all those consonants as one alphabet, you are actually having 5 alphabets. 1 in that box, all the consonants in that box, so that is my one alphabet and 4 I's. So in how many different ways they can arrange among themselves? Factorial 5 divided by factorial 4. Why? Because 4 I's are identical, correct? Now inside that box, there are 4 A's, 2 P's and 1 M. So total there are 7 alphabets. Now this can arrange among themselves in factorial 7 divided by factorial 4 because of 4s and divided by factorial 2 because of 2 p's. Is it clear? So the total number of arrangements where all the consonants are together is factorial 5 by factorial 4 into factorial 7 divided by factorial 4 into factorial 2. Is it clear to all of you? Absolutely. Okay, let us move for the next point. Relative position of vowels and consonants do not change. What do you mean by that? The relative position of vowels and consonants do not change. It means that your consonants are at some places and your vowels are at some places. Your consonants now can arrange among themselves, but in the position where the consonants are residing, you cannot change the position of the consonants. You can change the alphabet in that position only, but you cannot change the position. Means if the consonant is in the third place, you cannot take that consonant in the second place if suppose in the second place no consonant is there. You cannot take it there. Same thing with the vowel. That is what is called your relative position of vowels and consonants. So in this question they have said that the relative position of vowels and consonants do not change. That is what I want to say. Just see this one. I'm writing it here. We are having M-I-S-S-I, S-S-I-P-P-I. So where are the vowels? These are the 4 vowels, right? These are the 4 vowels. And they are in this position. So now your vowels can interchange among themselves in these 4 places. Though even if they interchange, we are going to have only one way because 4 eyes are identical. That's a different issue. But your vowels will never change the position. The 4 vowels are in the 2nd, 5th, 8th, and 11th position, right? These 4 positions should always remain same for all the 4 vowels. They cannot, the position cannot change. That is what is called your relative position. And the consonants are at this point, these 2 points, these 2 points, these 2 places, right? So now, in how many different ways these consonants and vowels can interchange their places to form different words such that their relative position is not changed. So, we are having actually 4 vowels, and these 4 vowels can interchange among themselves in basically one way. So, I'm not writing that because factorial 4 divided by factorial 4 will give us only one way. So 4 eyes, they are at the 2nd, 5th, 8th and 11th position. So at this position only these eyes will be there. So there is only one way in which eyes can be placed at these 4 points. At 4 places. Now the consonants are 1, 2, 3, 4, 5, 6, 7, right? There are 7 consonants. Now they can interchange among themselves in factorial 7 different ways, but divided by, there are 4s. So it has to be divided by factorial 4. At the same time, there are 2 p's. So they can interchange among themselves in factorial 2 different ways. Therefore, the total number of ways where the relative position of vowels and consonants do not change is basically factorial 7 divided by factorial 4 into factorial 2. That's it. That's your answer. This is the answer for question number 5. Is it clear to all? Have you understood what do you mean by relative position? The position where the vowels and consonants are already has taken their place will not change that place. If the vowel is in the 2nd position, other vowel can come in the 2nd position. There is no harm. But vowel will be in the second position. That is what is called your relative position of the vowels. Is it clear? Okay, let us see the next problem. There are exactly 6 alphabets between 2 P's. So the alphabets are arranging among themselves to form words, but exactly 6 alphabets are there between that 2 P's. So now you tell me how many such words can be formed. Okay, let me do one thing. Now we are having 11 alphabets. So we have to place 2 P's in these boxes in such a way that there will be exactly 6 alphabets between 2 P's. So let me place what are the options where the P's can be placed. One position can be this one and 1, 2, 3, 4, 5, 6. 2 P's can be settled here, or 2 P's can come here and here, or it can be like here and here, or it can be here or here, right? So there are 4 such places where you can place these 2 P's in such a way that we are having 6 gaps in between. Is it clear? Now we are having 11 alphabets, out of which 2 P's are already taken. So we are left with 9 alphabets, and out of these 9 alphabets there are 4 S, 4 I's and 1 M. Right? Now we are having 9 places after placing 2 P's according to our want. So these 9 places can be arranged by all these 9 alphabets in factorial 9 divided by factorial 4 into factorial 4 different ways. Am I correct or not? Now this is for one position of 2 P's. Now there are 4 such position of P's. So total number of ways will be factorial 9 divided by factorial 4 into factorial 4 into 4. Why 4? Because there are 4 such positions of P such that in between there will be exactly 6 alphabets fitted. Is it clear? Therefore the total number of ways in this case where there are exactly 6 alphabets between 2 P's will be 4 times factorial 9 divided by factorial 4 into factorial 4. That's it. Calculation again, I'm not going for it. You can do it by yourself. But have you understood the logic? Okay. So let's move for the next problem. Now in this question, they have said find the number of arrangements of letters of the word education such that vowels occur in alphabetical order. What do you mean by that? You have to form words in such a way that vowels will be always in their alphabetical order. That is, it should be in the order A, E, I, O, U. Wherever it goes, whichever word you see after the permutation, I will always see in that word your A is coming before E is coming before I is coming before O, and O is coming before U. That I must see. Whatever word you form, this alphabetical order of the vowels should be there. So how to do this sum? Let us say we are having this word like these 5 vowels are together. Then we are left with D, C, T and N. This can happen. This is accepted. All the vowels are together. I don't mind. I don't mind in this case. All the vowels are together, it's okay. But in this word also, I can see that the vowels are in alphabetical order. That is the only predetermined condition. So this order has to be maintained whatever word you form. Even if the word is like this, A, D, E, I, T, O, N, U. I don't mind. Have I written everything? A, D, this is D, anything is left I think. A, D, oh, C is left. So C can be written here. No problem. But in this case also you see the predetermined order is maintained. Like A is first, then E, then I, then O, then U. So I must get this kind of words where the vowels are maintaining its alphabetical order. That's exactly what we have to do. We have to find out how many such words can be formed. How to do that? How to do that? Let me do one thing. This is a unique method that I am telling you. A wonderful method I am telling you. And try to fill the sum, what I am going to tell you now. If I treat all these vowels as identical, what will happen? What I'm saying is, I'm saying that A, E, I, O, U, I'm treating those 5 vowels identical. It means what? Wherever it goes, doesn't matter. Even if they interchange their place, doesn't matter. To me, it is always A, E, I, O, U. If they are identical, even if they interchange their places, it remains same to me because they are identical. So if I treat all those vowels identical, then even if they arrange among themselves, it doesn't matter. My predetermined order is maintained. Tell me yes or no. What I'm saying is, suppose if I take A, E, I, O, U, all these alphabets are identical. So if these alphabets arrange among themselves, that is, if say A, I, E, O, U comes, to me, it is same as A, E, I, O, U. Because if 5 alphabets are identical, even if these 2 interchanges their places, it does not matter to me. It remains same that 5 is. So the best way of doing this problem is that you treat all those vowels as identical and let them arrange. Let them arrange with the other consonants. So what will be the total number of ways? Education, we are having 9 alphabets. So they can arrange among themselves in factorial 9. But we have assumed these 5 vowels are identical. So it has to be divided by factorial 5. So my answer will be this. Have you understood what I want to say? They have said that the order of the vowels should be in alphabetical. That is, first A will come, then E, then I, then O, then U. This predetermined order should be maintained. So what I've done, because during arrangement, these vowels can interchange their places. But if we treat those 5 vowels as identical, then even if they change, it doesn't matter to me, because to me it is same as, the order is same as A, E, I, O, U. Wherever it goes with the consonant, doesn't matter. My order is A, E, I, O, U. Are you getting the point? Therefore, the total number of arrangements where all the vowels occur in alphabetical order is factorial 9 divided by factorial 5. That's it. Is it clear? Okay, let's move for the next problem. See this question. In how many ways 7 students and 5 teachers can be arranged in a row such that let us consider the first case only. Students are in increasing order of weight. Now, whenever in the question you find that the order is predetermined, whenever you see that your order is predetermined, always take those values or alphabets or whatever is given identical. All those objects you should treat identical. Are you getting my point? So in this case, what they have said, there are 7 students. Let us say the students are. Now, let us say the weight of S1 is less than S2, is less than S3, is less than S4, less than S5, less than S6, and less than S7. Correct? So these are the 7 students whose weight are in increasing order. So this order is already predetermined. So what I will do, I will take these 7 students as identical objects. All those 7 students are identical objects. So when they arrange with the teachers, they can go anywhere. I don't know where it is going. Maybe the weight, not maybe, it will happen that their weights are not in the increasing manner. But to me, if I treat those 7 students as identical, for me, in every arrangement, the students are always in the increasing order because they are identical. Even if they interchange their places, to me, they are always in the order S1, S2, S3, S4, S5, S6, and S7. That's it. Is it clear? So in how many different ways these 7 students and 5 teachers can arrange among themselves so that students are in increasing order of weight? The total arrangement will be factorial 12. Why? Because there are 7 students and 5 teachers. And this will be divided by, since 7 students we have taken identical, so it will be divided by factorial 7. And that will be the answer for question number 1. Is it clear to you? Is this clear to you? So what I have said, write in your notebook that whenever order is predetermined, you take those objects as identical objects and then find out the total number of permutations accordingly. Okay? We know that total number of arrangements will be what? The total number of objects, factorial, divided by the identical objects, and that's exactly what we have done in this case. Is it clear? See the second one. Teachers are in decreasing order of weight. Let us say my teacher T1, there are 5 teachers, T1, the weight of T1 is more than T2, more than T3, more than T4, and the less weight is T5. Okay? So the order in this case is first T1, then T2, then T3, then T4, then T5. Wherever it goes, this order is predetermined. This order should maintain in that arrangement. We are having 7 students. So along with the students, these teachers can arrange among themselves in factorial 12 different ways. But since we have taken those 5 teachers identical, therefore it will be divided by factorial 5. That's it. Therefore, the total number of arrangements where all the teachers are in decreasing order of weight will be factorial 12 divided by factorial 5. Is it clear to all of you? Again, I'm telling you, whenever the order is predetermined, take those objects as identical. Identical. Then only that order will be maintained throughout your permutation. Is it clear? See the third one. The third one says students are in increasing order of weight and teachers are in decreasing order of weight. So now the 7 students, they will sit according to their weights in the increasing weight. So it's a predetermined order. So what I'm doing is I'm taking the 7 students identical as well as and, because in the question and is given. The 5 teachers will be also in a predetermined order, that is in decreasing of their weight. So we are considering there are 12 objects. That is 7 students and 5 teachers. We are treating this thing as 12 objects. So they can arrange among themselves in factorial 12 different ways. But it will be divided by, as 7 students we have assumed identical. So it will be divided by factorial 7. And at the same time, your 5 teachers are taken to be identical. So it has to be divided by factorial 5 also. Therefore, the total number of ways where the students are sitting in their increasing order of weight and teachers are sitting in a decreasing order of weight is factorial 12 divided by factorial 7 into factorial 5. I hope the thing is very clear to you. Whenever, again I'm telling you, whenever the order is predetermined, always take those objects as identical and you will get your answer. Is it clear now? Let me take another problem. See this sum. The question is, find all possible arrangements of the letters of the word, again the same word, education, such that E comes before A. See the first question. E comes before A. So this is the predetermined condition. The order will be what? Any word you form by taking all the alphabets of the word education. But always your E will be, it will come before A. Wherever it goes, whatever a word we will see, we will always see that E is first and then A will come. So what I will do? I will take this E and A are identical. So we are having, actually in education we are having 9 alphabets. So 9 alphabets can arrange among themselves in factorial 9 different ways. But since we have taken E and A are identical, so it will be divided by factorial 2. That's it. That is the answer for the first one. Is it clear to all? Let us see the second question. Question number 2 states, E comes just before A. E comes just before A. What do you mean by that? That whatever word we can see, your E is coming just before A. That is, what I will do is, I will simply make E and A as these 2 alphabets I will take in one box. And now I will treat this box as my one alphabet. So now we are left with D, U, C, T, I, O, N. Okay? Now, in how many different ways this whole alphabets can arrange among themselves? They can arrange among themselves in 1, 2, 3, 4, 5, 6, 7 and 8. So they will be arranged among themselves in factorial 8 different ways. Now somebody can ask me one question. Sir, E and A, they can also interchange among themselves. So that can be done in factorial 2 ways? No. Because if they interchange among themselves, think about it. If they interchange among themselves, that is, if A comes first and E goes second, then your E is coming after A. But what is the question? E comes just before A. Is it clear? That is why I cannot go for this multiplication. I cannot go for this multiplication. Is it clear or not? Therefore, my answer will be what? It will be only factorial 8. Am I correct or not? Now, what is the third case? It states that E comes before A. and A comes before N. So again, there is a predetermined order. What is that order? Your E comes before A and A comes before N. So wherever this EAN is there in the word that will be formed, this order has to be maintained. First E, wherever these three alphabets are there, first will be E, then A, then N. Different alphabets will come in between, at the side, at two extremes also. Doesn't matter to me. But in all those words, E will be the first one. E will be the first thing that I will see, not the first alphabet of that word. No, it can be anywhere, but it is the first E, then A will come, then N will come. This predetermined order has to be maintained. So what I will do? I will simply take this E, A, N are identical. They are identical. If they are identical, what will happen? How many number of alphabets are there? Total, there are 9 alphabets. So in education, there are 9 alphabets. So 9 alphabets can arrange among themselves in factorial 9 different ways. But the predetermined order EAN, these 3 are identical, so it has to be divided by factorial 3. Therefore, total number of ways where E comes before A and A comes before N is factorial 9 divided by factorial 3. That's it. Is this clear? Very interesting, isn't it so? Whenever you find that there is a predetermined order, always take those objects as identical. That's it. That's the only conception that I taught you right now. Is it clear now? Okay, let us see number 4. E comes before A. U comes before I. And C comes before N. Have you understood this? E comes before A. U comes before I. And C comes before N. So what is actually happening? Whatever word I will see, I will always see that E is always before I. And I will see U is always before, E is always before A, And U is before I. And C is before N. So how to approach this sum? What I will do in this case is, I will treat EA as identical objects. UI are the identical objects and CN are identical objects of different kind. EA is identical objects of one kind. UI is the identical objects of another kind, and CN are the identical objects of another kind. So if we consider these alphabets are identical of one kind, let us say E and A, then wherever this E and A goes during permutation, it doesn't matter to me. Even if they interchange their place, it doesn't matter to me. To me, it is always A is after E or E is before A, whatever way you say. In between, other alphabets can come, doesn't matter. But my E is always before A. Same thing with the other two alike objects. Is it clear? Therefore, the total number of arrangements will be, here there will be 6 and we are left with 3. So actually total alphabets are 9. So they can arrange among themselves in factorial 9 different ways. But it will be divided by factorial 2 into factorial 2 into factorial 2. And that will be the total number of arrangements where your E comes before A, U comes before I, and C comes before N. Is it clear? Because we have taken those objects as identical. So there are 3 identical objects of different kinds. That is why I have divided by factorial 2, and factorial 2. Right? Okay, let us see the last problem. That is, E comes before A, and A comes before D. U comes before T and T comes before I. So what is the predetermined order? That your E will come before A will come before D. So I will treat E, A, D as my identical object of one kind. Then they have said U comes before T and T comes before I. So U, T, I will take identical objects of another kind. Getting my point? So total number of arrangements in this case will be factorial 9 divided by, why factorial 9? Because there are 9 alphabets total, divided by factorial 3 into factorial 3. So that will be the answer for the fifth one. Is it clear? So this part is a very, very unique a way of doing this kind of sum when you find that the order given is predetermined. We will always take those objects as identical objects and we will divide it as we have done when we have permuted the alike objects. Is it clear to all? So that's all about your today's lecture. We will be meeting very soon. Till then, stay tuned to us. Don't forget to subscribe, like and share. And definitely comment me if you really want something else for your preparation. Till then, thank you and take care.